Well, hello and welcome. In this presentation, I will be looking at reducing balance loans and in particular how they may be implemented using recurrence relations. In summary, our recurrence relation for a reducing balance loan is Vn plus 1, so our next value equals our current value, which has been increased due to an interest component and it's been decreased via a loan repayment component. And that's what has been implemented here or written here. And a typical example of a reducing balance loan may be a home loan. Now, here is our recurrence relation. What you can see is that AJ has started with $1,000 and he's paying 5% per annum interest, which is an annual compounding interest, and he is making a repayment of $100 per year. So effectively, he starts at $1,000. His loan will increase by 5% and it will decrease by $100, and this happens every year. So start at $1,000, multiply by 1.05, subtract 100. So after the first year, his loan will now be $950. Second year, same mathematical operation will occur. Multiply by 1.05, there's our increase of 5%, and then decrease by $100, which is our loan repayment. And this will go on until his loan is completely repaid. Now, what I've described there, those steps, can be represented in what's called an amortization table. Now, here is a typical table, not for AJ, but just for another, well, this is the situation where there's a loan for $200,000. Now, a regular payment happens every period of $1,297.20 is made. And an interest calculation has to be made for every period. So you can see here, the first interest payment will be based on a balance of $200,000. Now the difference between the interest payment, which is increasing the loan, and the payment, which is decreasing the loan, is made in this column here, which is called the principal. It's the change in the principal. And then that value there is subtracted from the balance of the loan to give a new balance. Then that figure there will be used as a basis to calculate the next period's interest payment. This basically will go on until the loan has been exhausted, has been paid off. Now, you can, if you wish, generate this particular recurrence relationship on your calculator. Now, I'm actually going to skip over that page and just move to the next slide. But if you wanted to do that, you'll effectively 1,000, then hit enter, and then times 1.05 minus 100, enter, would give you that value there. And if you hit enter again, you'd get that value there. Enter again, you get that value. So I'll skip over that and move more to the Finance Solver application, which is on the TI-Nspire calculator. This is where things get quite exciting and quite interesting. Now, with the TI-Nspire, there is an app which contains 6 meaningful fields that we deal with. What happens? we will populate 5 of those fields, hit enter, and the 6th field, the one that has not been populated, will be give us an answer. Now, the fields that we deal with are the total number of payments for the duration of the loan, how many payments. I is the annual interest rate. PV, the present value of the loan. Now that is, how much have I borrowed? Payment, how much will I be making as a payment per period? Future value now is, at the end of my loan, how much is still outstanding to pay? Typically with a reducing balance loan, that will be 0, but it does not have to be 0. And the number of calculations that are made and the number of payments that are made per year. Those two are actually tied together. We normally just have the one value for both of those. Now, it's important to note that the present value, the payment, and the future value, they're all basically all the variables that contain dollars have a sign component. They may be either positive or negative. Now, when their sign is positive, this represents money that is flowing from the financial institution to the borrower. And when their sign is negative, this represents money that is flowing from the borrower back to the financial institution. It's very important to keep that in mind, and I will dwell on this particular concept as we move from example to example. Now, we're going to look at this first example, which is on the next slide as well. Okay, let's look at this first example. Now, consider Lavinia. She borrows $200,000 at an interest rate of 4.5% per annum, with interest compounding every month. Now, we want to calculate her monthly repayment if the loan is going to be paid out in 20 years. Now, what I need to do is scan through this question and populate the fields that I know and also identify what I'm being asked to calculate. Now, first thing that I typically like to do is look to see my calculation period, my repayment period, and I can see here that interest is compounding every month. So right away I know there are 12 payments every year. The next thing I look at is, well, okay, I'm going to borrow $200,000. Well, Lavinia is actually borrowing $200,000. So that is how much is being borrowed. It is a positive $200,000 because the money is going from the financial institution to Lavinia. Now, the next thing I notice, the interest rate, 4.5%. Now, the next thing is the future value. Well, we're going to pay out the loan in 20 years, so the future value will be 0. Now, the next thing is, I know there will be 20 years of payments, which will happen every month, so the total number of payments will be 20 times 12. And the last thing, which we'll always keep this at end, is the payment, which is the thing that needs to be calculated. So I'm going to try and remember all those values. I'm going to minimize this and go to my calc. We know it's 4.5%. 200,000 is being borrowed. We wish to pay off the loan, so the future value will be 0. Calculations are made every 12 or every month. 12, so there'll be 12 months in a year, and there will be 20 years worth. So what you can do here is just do your straight calculation, 20 times 12, and when you tab out of this field, you'll notice that the actual calculation is done for you. Last thing that needs to be calculated is the payment. So I've got every other field populated, hit enter, and you'll notice that the payment is $12.65 and rounding that 30 cents per month. So I'm just going to minimize this back to the presentation. So the payment would be $1265.30. Notice here a negative sign. Negative sign indicates that the money is going from Lavinia to the financial institution. Just moving on. Okay, we're going to look at the second part of the example with Lavinia. Now, after 10 years, the interest rate has increased to 5.5% per annum. And we need to recalculate a new repayment. Now, what I need to do is say, well, how much does she currently owe, or how much does she owe after 10 years? So I would actually do this calculation here, paying 4.5% per annum, originally borrowing $200,000, paying at $1265.30, which I calculated from part 1A, gives me a future value of $122.87. In other words, after 10 years, Lavinia owes $122,087.82. Now, what I need to do is consider that as the starting point for a new loan, which is going to be calculated for the next 10 years. So, whoops, seem to have lost. So, what you'll see here, for the next 10 years, we will start with $122,087.82. We'll now be on the new interest rate of 5.5%, and at the end of that second 10-year stint, Lavinia will owe zero, which basically means that her new repayment is $1,324.97. So it is a considerable increase from the original repayment of $1265.30. Perhaps from that you can perhaps get an understanding or an appreciation why homeowners really worry about interest rate increases. So moving on to the next slide. This is a question from the 2011 Further Maths exam number 2. Now, Tanya takes out a reducing balance loan of $265,000 to pay for her house. Her monthly repayments will be $19.80. Now, interest on the loan is to be calculated and paid monthly, and the rate is 7.62% per annum. Now, we're being asked to calculate the monthly repayments. Now, how many monthly repayments are required to repay the loan? And we need to answer to the nearest month. So what I need to do is effectively, for all the fields in the Finance Solver app, I need to populate them with a value, and one of them will be left blank, and that's the one where the calculation will be performed. Now, looking at this, it's saying how many monthly repayments. So that's basically what I'm being asked to calculate, the number of repayments. Then I just go through and populate the rest of the fields. Now, I am taking out a reducing balance loan. Well, that's the signal right away that I'll use my Finance Solver app. $265,000. So that is what I am borrowing, $265,000. Now the monthly repayment is $19.80. So there we go. Negative, indicating that I am paying money back to the financial institution that's coming out of my pocket. Now, the future value. Well, let's go through and keep reading. Now, the interest rate is 7.62%. There we go. 7.62%. Now, how many monthly repayments are required to repay the loan? Well, if I'm going to repay the loan, then the future value will be zero. I know that this is being paid monthly, so there are 12 months in a year, and my calculation will be performed at the end of the month. So there's all my information, all the fields populated. Here's my blank field. Do the calculation on my TI-Nspire. I end up with $299.57. So this will be rounded up to 300, so there will be 300 repayments. Now, the next part is I need to determine the amount that is paid off the principal in the first year. Now, what I need to do with this is now for part 2 of this question, I need to determine the amount that is paid off the principal of this loan in the first year. Write your answer to the nearest cent. Well, these values have not changed. Interest rate still the same, present value still the same, payment still 1980, still 12 payments per year. Now, I'm being asked I need to calculate the future value, and the future value is going to be after 12 months. Well, because I'm being asked for the first year. And if I put those values in my calculator, I'll end up with a future value of just over $261,000. Now, the question going back is, how much is paid off the principal? Well, that's how much I still owe. That's my original starting point for the loan. So my answer will be, well, the $265,000 minus what I still owe, which will round to $3,694 and 25 cents. So unfortunately, I've only paid just a touch under $4,000 off the actual principal of that loan. So still got a lot of payments to do. So there you have it. Now that's the end of my slide presentation. I hope that this presentation has provided you with an understanding of the reducing balance loan, and in particular how these are implemented using the recurrence relation. So until next time, bye for now.